Good afternoon. Thank you for joining today. We're going to go over the JBT overview. My name is Bill Paus. I'm Senior Project Manager with JBT Corporation. I've been with JBT for 22 years, ranging in responsibilities from installing systems through managing field service department and now working through the project management group. Overview of JBT, if you're not familiar with JBT Corporation, is we've installed, our automated system division has installed over 4,500 vehicles around the world. In addition to our experience in installations, we provide support in our customers with a lot of different vehicle designs. We have custom vehicles, but at the same time, we have standard vehicles. We look to fit our designs and our expertise to our customers' needs. We have strong financial resources with proven stability. We're ISO 9001 certified. We also provide 24-hour technical support hotline. We also have a very large R&D department continuing to advance our technology and looking at new methods and technology and perform automatic software upgrades as well. JBT overall constitutes 3 different divisions. We have annual revenues of over $1.9 billion US dollars. We're broken into 3 groups. Actually, 2 major groups, our Food Tech division and our Aerotech division. Food Tech is working on the food processing industry from beginning to end, and then our Aerotech doing airport system support. Automated systems doing automated solutions for material handling through the use of AGVs is actually under the umbrella of the Food Tech division. So actually we are a much larger organization supported by our corporate entity. So our JBT was founded in 1884. We have progressed from, some people may know us as FMC, then we became FMC Technologies. Today we are JBT Corporation. JBT is named after our founder from 1884, John Bean. So that's where the name JBT comes from. We have over 5,800 employees worldwide and working in over 100 countries. Our headquarters are located in the United States out of Chicago, Illinois. So some of our offerings, you'll see here different vehicle types. So we have what I would call some standard vehicle types in our towing special applications. So you'll see unique applications here. You see a missile carrier. That was quite a unique project. We'll see unit loads, fork vehicles at the Plastek facility. We utilized a fork vehicle solution. We also have some automated kits. We have partnerships with Crown, so a standard Crown tugger can actually be driven manually with a man aboard, but it also does contain JBT automated guidance systems so that it can operate in automatic. We also have a fork solution that is also what we would call an off-the-shelf Crown vehicle, but containing JBT control. So this vehicle can be operated in manual and in automatic should there be the need. We also provide all of the software both on our vehicles and for our system control. We have systems running as many as 250 vehicles within a single system, doing traffic management, order control, and all of the system level interfacing with customers, WMS and ERP systems as well. Our safety record, so we're part of ANSI B56.5 is where we follow. We've been operating automated guided vehicles in some variety from wire guided, laser guided, natural feature guided for over 35 years with over 500 installations and over 4,500 vehicles in operation. We have members of our organization on the safety committees of both the ISO 3691, ANSI B56.5. We're also members of MHI and ASTM F45 committees. So we are engaged with the industry and looking to provide overall safety solutions. Why automate? Labor shortages, turnover, constant training costs is certainly a reason and opportunity for automation. Injuries with existing equipment, products, so lost, misplaced, damaged product. With the ability to have inventory control, we're able to track that inventory and identify it within our system. Lack of skilled labor in today's environment, skilled labor is very difficult to find. So by automating, we have a consistent labor force. Abuse of manual vehicles. If anybody's been into a shop and looked at a manual forklift, you often see marks, scrapes, dents, damages. So definitely would improve in damage to the manual vehicles. The automation is meant to obviously not contact. There's traffic management involved in the systems as well. And then limiting production, right? You have multiple shifts, vehicles work multiple shifts through. So it's a very consistent and predictable behavior. So let's look at the project at Plastek Hamlet location. The project overview. So at the Hamlet location, we have 25 AGVs. They're fork vehicles. They are natural feature, meaning that we are looking at the environment. We are looking at the environment for our feature navigation, all the software. So in addition to that, we are supplying the software and control systems to interface with 51 molding lines, 9 assembly lines. Also the warehouse, we're performing block stack storage and retrieving finished goods from the assembly machines and bringing them to the block stack area as well. Vehicles are powered by a lithium-ion battery with an approximate 7-year of lifetime. We are monitoring the battery levels and routinely will send them for charging when the levels get to when the battery comes to a lower level. We'll actually generate a charge order, automatically send them to the charger, and charge those batteries so that they can be returned to service. So overall features and benefits: safe, proven vehicle software platform, a proven vehicle design, lithium-ion battery technology, service, and our products are made in America in Kingston, New York. So if we look at the safe, proven vehicle software, so we have been, our software, our systems typically run 24/7, 365 across many Fortune 100 companies, controlling as many as over 200 vehicles in a single system. Our systems realize better than a 98% uptime and less time recovering any vehicle errors and doing productive work. So the vehicle is our vehicle is custom designed for Plastek to utilize, their product. We make sure that we find the right vehicle that matches the product use, looking at lowering our cost and providing the most cost-effective system. There are manual controls that come with the vehicle, so that should you need to manually move a vehicle or perform a task manually, it is available. There is a handset and there are manual controls. Very clean and easy to follow screen for putting the vehicle back into service. So the Plastek system is using a lithium-ion battery solution. It is a solution that we prefer to use. The advantage to a lithium-ion battery is that, one, it can be charged quite quickly, quicker than a lead-acid solution. And they also don't need to be watered. So if you're familiar with a lead-acid battery, needs to be what they call equalized in water. Batteries come with multiple cells in them. So they need to perform a maintenance task, which means, you need to purchase more batteries than you would have vehicles, such that you could do this maintenance process, which can take anywhere from 12 to 24 hours. Lithium-ion batteries don't need that process, and in a system this size, provide us a good advantage. You also can charge a little bit faster. So the size of the battery, you don't need as large of a battery because you can charge faster and more often. Training. So with the vehicles, we provide training of your maintenance personnel to perform regular preventative maintenance processes and unscheduled maintenance as necessary. We also provide training for your operators, whether it both be IT, so an operator that's managing the system, or if it's from a GUI interface or a manager interface, or an operator that is handling the vehicles. We provide all of that training. We also offer future training and additional training as necessary, provide different service options included with our ProCare support, which is something that is provided from our product support and service group. And as I mentioned before, our vehicles are built in America. They are, we have an engineering facility in Chalfont, Pennsylvania, so we do all of our own engineering. Our production and manufacturing is located in Kingston, New York. So all of our vehicles that we provide are made in America. Critical success factors. So I know that Plastek was looking for JBT to deliver real-time information system with state-of-the-art best-in-class AGV. The other criteria is obviously we would need to interface with the current SAP system. So we actually have a web interface that does talk to the Plastek WMS system that we interface. We transfer inventory information, movements of the AGV, and through that they are able to keep track of all the inventory in the system. So several areas of work. We talked about molding production. So within the molding room, so how the vehicle works is the operator will place a UniPack. So we see a UniPack here. If we're watching the machine, they can deposit product in one or the other side. The vehicle will approach the UniPack. Prior to engaging the UniPack, we actually have a sensor that looks at the load to determine its location laterally. The vehicle will side shift the forks, looking at the pocket. Once the forks are side shifted in position, the vehicle will drive in reverse, engage the UniPack, pull forward, and then exit the location. Once this UniPack is removed, the operator will replace that empty location with an empty UniPack, such as shown here. And then we'll move over to the second location when an operator calls for an AGV. And then it goes and it leaves. Okay, in the assembly area, so in the assembly area, there are 9 assembly machines. Within those 9 assembly machines, there are 5 locations in which we drop parts that create a full assembly. So those parts coming from the molding line are supplied to the assembly line. Now, when an order or request from an assembly line comes in, the system has has 2 options. One option would be to pull that inventory from a newly picked up molding line. So if we get an order from an assembly machine to deliver product, if we've just recently picked that product from a molding line, we will redirect it to the assembly machine. That creates some efficiency in the system, you know, no deadheading in the vehicles. So it's just a very efficient process in order to maximize the time or minimize the time to deliver to the assembly line. In addition to delivering product to the assembly line, we also retrieve, as you see in this video, finished goods. So as the assembly line is going through and making a finished product, similar to the molding line, the operator will signal for an AGV to come and pick up the load. The vehicle will come, pick up the load, and then now take it over to a staging location located in the warehouse. Warehouse storage. So within the warehouse location or the warehouse area, our lanes are configured 4 deep and 6 high. So each lane consists of 24 UniPacks. Warehouse contains over 550 storage lanes in total, housing over 26,000 UniPacks in the system. So how we do storage is we actually do the storage based on a batch ID attribute as received from the Plastek system. Now we can monitor up to 20 inventory attributes per a single piece of inventory, and we can store those by utilizing any of those inventory attributes. So if your desire would be to store it by SKU and product made today, then we can set our algorithms up to maintain lane accuracy of all product that has the same SKU and produced at the same time or the same day. Once the day turns to tomorrow and we flip, we would actually create a new lane and be able to continue storing in that fashion. So we do have custom software that will allow us to essentially set your storage rules. So when we do warehouse put away, the vehicle decides, again, based on those inventory storage attributes, we decide what lane to deliver the product. We will pull to the desired lane, confirm to our SGV managers, we would call it, or our host control from the vehicle that it has arrived at the location. We'll raise the UniPack. We have sensors, so what we will do is we will use, so there is a, if you can see it here, there is a camera underneath the UniPack. That camera looks at the stack that we are looking to drop on, confirms the lateral location and the depth of that existing stack, makes the modifications to the algorithm for the vehicle, reverses back above that stack, does another check, confirms the location, and it will actually side shift either right or left according to the feedback from the camera prior to placing the load. So in a 25 vehicle system, we actually have to maintain some traffic control. So we do, our SGV manager system will manage the fleet. It decides who goes first, who waits on who. So we see in this video, we see 2 vehicles operating in close proximity to one another. You know, we also see vehicles waiting in the background. So our traffic manager allows the smooth flow of the vehicles throughout the system, and that's all controlled. So it is not very sequential, where we will allow vehicles to pass and navigate in close proximity. Our SGV managers. So this is our SGV manager. This is basically our control system. So this is a graphical user interface into our control system. You can see here, you can do a customized view. So here you see multiple viewports. We can look at an overall view. There we can also view orders, an individual SGV, the inventory, even specific diagnostics per vehicle if necessary. So we actually do end-of-line operations. So you'll see typical applications may be off of a conveyor into warehouse rack storage. As we're doing at Plastek, we're doing block storage. We can do rack storage, drive-in racking, selective racking, pushback racking. So we can interface with not only block storage, but we can also do racking operations. Finished material outbound. So we'll show a little bit of future project with Plastek that we're in the process of implementing, would be our trailer loading application. So we would come from our staging location, we would actually load trailers to go either to a storage facility, or we can load trailers that would go to an end user or a customer. So if we look here, we see trailer loading. This is a automatic truck loading, or what we call ATL. The vehicle navigates into, it's using the walls of the trailer to navigate. We have dock interface. Then the vehicle will actually drive into, senses the loads. We track the inventory in the trailer, place the product in close proximity to one another, and can fill a trailer. We can do both wide orientation. We can do narrow orientation. We can also we can pinwheel if necessary. So that is also an option to us as well. Oh, sorry, I skipped a slide. So again, the trailer loading is a future application within the Plastek organization that we're looking to implement not only at Hamlet, but at their storage facility as well. Just a little bit better view of the ATL, or trailer loading vehicle. It is what they call a single double. So for efficiency, when possible, we would carry 2 loads at a time, which would fill out the trailer with. This attachment also can be collapsed to be a single attachment as well. So we can handle single loads and double loads with this vehicle. You'll also notice a little bit different drive configuration. This vehicle has dual rear drive. We found that very effective in our trailer loading going over dock plates. You'll also notice, if you look at your trailer applications, that there's a lot of incline and decline within the trailers depending on what your dockyard looks like. So it's a little bit close up of the future vehicle. Our contact is our national sales manager, Rick Karen. His information is located here if necessary. And I think Nicole will be able to share that with you. And that's all that I have. Thank you. Nicole?
Thanks, Bill. We're going to give Bill a couple of minutes as we wrap up with our session today. We have one segment left during our presentation within the Plastek Academy presented by JBT this morning. So I want to thank all of our Plastek Academy viewers for joining us today. And we have the opportunity, of course, for anybody who's not familiar or have just begun working with JBT. I know we have a variety of audience members on, from purchasers to technicians to some of our own Plastek team, as we're learning and experiencing. As Bill announced, that we do have these in our Hamlet location down in North Carolina, which was great to see the videos of everything in action and hear about the support that they can offer us. So we are here to answer any of your questions that you have left from Bill's information he shared with us today. You can see on the screen here, you have the opportunity to use the dashboard to write in your questions, and we can get a few of those answered for you today. So please take a moment to do that. And for those of you unfamiliar with our GoToWebinar dashboard, before we come back and answer some questions, we also have a handout section located on your dashboard where you can open the PDF and download at your convenience or print off to share with your team. JBT has provided a PDF document, and I've got mine right here, so you can have that at your hands after today's closing of the Plastek Academy presentation. So we will bring Bill back and we'll get started with some of our questions with our remaining time.
Hi, Nicole.
All right, Bill. So Bill is our expert from JBT again, and one of our questions that we have here is asking about the weight limits. So we saw a variety of machines, as you mentioned. You guys have helped us customize to meet our needs in Hamlet, different pallets, one pallet, single pallet. So are there pallet weight limits per load using JBT equipment?
So we design each vehicle, so all of our vehicles are designed to handle the load that's requested, right? So in the Plastek environment, a single UniPack, you're looking at around 500 pounds is the design criteria. That vehicle, as you see it, has got about a 1,200 pound capacity. Some of that is limited by size, but we have vehicles that range up to 10,000 pounds capacity. So depending on the needs of the application, our capacities can accommodate that. The trailer loading vehicle that we showed in the back, that'll be handling 6 UniPacks at the same time, but that vehicle's overall capacity is about 5,500 pounds, handling 6 UniPacks.
Great. And as you talk about the variety of options you have available, I can show you guys the last page of that handout you want to be sure to open before you leave today. It does have several of those varieties listed there. Okay. So in some of the videos that JBT provided today on the screen, we saw a combination of equipment being used from your AGV equipment, and we saw a couple of our forklift drivers still using a manual piece. So one of the questions, we saw them stop and start, but can you just reiterate the efficiency and accuracy of vehicles being able to go around obstructions?
So the vehicles will not go around obstructions, but what they will do is they will detect obstructions. So the vehicles are outfitted with programmable laser bumpers. They both have a tower bumper. So the tower bumper projects in front of the vehicle. And then around the vehicle, there'll be 3 safety scanners. They're safety rated. They can range in view up to 5 meters in view for stopping. So we program them based on the vehicle speed. So should an obstruction become evident in front of the vehicle will stop. When that obstruction is removed, the vehicle will automatically restart and continue on its way with its mission.
Great. We love seeing new technology and being innovative, so some of these things and the loads that they're capable of is just amazing. We talk about the cameras there, and you mentioned the words in front. While it has a load on it, is it also on the aerial level, the higher levels, is it able to detect objects hanging?
So when we are, when the load is on board and we're placing objects, so that camera that we're using to only detect the stack, we're also making sure that the area is clear for dropping. So we are identifying that when we are placing the load, that we are also ensuring that the location is clear. So we're using that camera. There's a what we call a drop-down camera that is scanning that area prior to placing that load in its final destination. So yes.
Great. All right. Tangible obstructions and objects of identifying its fluency in operation. I have a question here. In the video, we noticed some wear and tear of the routine motions on the facility floor. You can kind of see some as it moves in a circular motion. So have you ever seen it obstructing the accuracy of the performance and movement of the machines? And does it affect them needing repaired more often?
You're referring to the floor conditions?
Yes.
Yeah, so the vehicles are very repetitive in their motion. So over time, we see that the wear can actually take place at the drive wheels more than the floor conditions. In this scenario, we do like expansion, so we do want to make sure that the floors are smooth and repaired of imperfections. So large expansion joints, you'll look at warehouse facilities, you'll see expansion joints. They may have chips, cracks, and they can expand over time. So we do request that expansion joints greater than 1/4 to 1/2 inch wide that have damage, that those be repaired. But we certainly do prefer excuse me, a smooth surface. when traveling. But as far as floor markings or over time of the AGV and the floor, that should have no impact on the vehicle's navigation or behavior within your site.
Wonderful. Okay, let's see, I think we have 2 more questions to recap some of the information and just familiarity with how all the systems work and being integrated, running on their own, the software systems, working behind the scenes with the IT department and all the networks. So if an AGV stops or errors out, how difficult is it to get it going again?
So there are red lights on the vehicle. So if the vehicle stops, you will see red lights flashing. That will signal it stop. Also, the GUI that we looked at, the vehicle will continue on its own in many locations.
We love safety, we love efficiency, all the resources and benefits that you guys can offer us in customer service. But if an AGV, as fast as they work, if it gets behind, is it difficult for it to pick back up and catch up in the schedule?
Yeah, so there's capacity built within the systems to do that. So if they get behind, there is some capacity to be able to catch up and maintain and return to a steady state behavior.
Okay. All right, and I do have one more good question that came in, so I will use this one as our last question now that we've got you back with us. From one of our members down in Hamlet who is working with you guys, and you guys are on site. I had a chance to meet you and Rick in person a couple weeks ago. So during this whole process, as involved as it is to set up the amazing number of machines that can run at one time and even within one facility, can you talk a little bit about the adjustment period between the time that the AGVs arrive at the facility to working out all the kinks within the system so that they can fully run and do what they're supposed to do?
Right. So typically the process is, so we need to teach the vehicles the location, right? So we do the navigation, the vehicles arrive, we need to actually go to many of the locations. If they're discrete locations, like in the molding area, we need to go to each one of those locations. And then we teach the vehicles, for lack of a better term, and confirm the guide paths, make sure that everything is safe from the bumper field perspective. When you get to a warehouse area, being that that's open space, we don't necessarily check every single location, we check pieces. The transition part, the challenge is always from an operator perspective, right? So performing that training so that the operators are familiar with the vehicles, the human interface. So I always like to say that the flaw of automation is where manual intervention comes into play, right? So the trick is that manual piece. So remember, we showed that your operators at Hamlet would be manually placing the product. So it's always a challenge. We've placed detents and guides to make that more positive for them. But that is the challenge, is just getting that process put through and getting the customer and the system to work together to be able to solve some of that manual handoff area, if you will.
Great. Okay, so we have gone through all of our questions from our audience today, and I want to leave everybody again with the handouts both from JBT and the Plastek group there on your dashboard before you leave today. And I have Bill's contact information up here still, so if anybody is interested, please jot that down, as well as mine, and we'll see if Bill has any closing statements before we show you your last slide and allow you a minute or two to gather your PDFs and move forward with your day.
Okay. No, I'd just like to say thank you for this opportunity, Nicole. I appreciate it. If anybody has any questions regarding JBT, certainly feel free to reach out to me. My contact information is there. or Rick Karen. I think his contact information was also provided. But I thank you for the opportunity, and it's been a pleasure working with Plastek, and will continue to do so.
Wonderful. All right, guys, as always from Plastek and the Plastek Academy, it was great to see all of you log in today. This is one of our last sessions this series for the 2020-2021. So if you've missed any prior to or want to rewatch this for some info, share it with your team members, anybody who can benefit from this as a resource within our industry. Please visit plastekgroup.com/plastek-academy or reach out again to myself on anything that you found interesting or would like to learn more about in the future. So we have one more coming up in September. We look forward to seeing you all again there. And as always, thank you to JBT, Rick, Angela behind the scenes, and Bill, who is with us here today. Thanks everyone, and have a great day.